Okay, one moment. Okay, we'll give it a couple moments. All right. We've got a couple of viewers, and I'm sure we'll get some trickling in. But as a heads up, this meeting is going to be recorded, or this workshop will be recorded. So for those participating in Hackmeter, you'll be able to come back to this any time. And feel free to leave any questions in the live stream chat or on Discord. And I will go ahead and pass the mic on to you, Jahan. So thank you.
Yeah, thank you, Annalisa. Thank you,
No
everyone,
problem.
for coming to the second workshop. In the first workshop, we talked about uh, the how to like start interacting with the Meter blockchain, and also how to deploy a simple ERC20 contract and get it verified. Since Meter is Ethereum compatible blockchain, I don't think I have to go in too much in detail regarding to how to program the Solidity contract, things like that. Those are widely available on the internet. So I will use this opportunity as a way to give everyone a little bit in-depth overview of the Meter blockchain's architecture. So you will know a little bit background, and also when you interact with the blockchain, the community, and the tokens, you have a better understanding of what it means and the underlying tokenomics of the blockchain. So first, let me just share my screen. Actually, let me just share my entire screen. So yeah, so let me start from the very high level. Basically, we see meter as a experiment on consensus design, starting from the root of the blockchain. So when you like talk to people in the blockchain space, I mean, like people keep on talking about the proof of stake or proof of work consensus, but those terms are not completely correct. Actually, neither proof of stake or proof of work is a consensus algorithm. They are just Sybil resistance techniques, basically to prevent Sybils. Basically means like, for example, artificially created nodes to attack the network. So basically, these are the ways to differentiate people who are sincerely participating or just like spamming the network. So basically, proof of stake assumes the majority of the token holders in the network honest, and proof of work assumes the majority of the computation in the network participating in the network is honest. Um, and also, if you look at the existing cryptocurrencies, there are actually two type of real consensus going on. One is an economic consensus. Basically, these are examples are like proof of work. So these are basically uh, through the competitive behavior of the miners as trying to discover the value of newly created currency. For example, if you look at Bitcoin, there are so many proof of work miners competing on the network in terms of cost, in terms of contributing contribution. But at the end of the day, it's a fully competitive competition, I would say. So for such a competitive environment, at the end of the day, the marginal revenue of the cost for the miners will equal to their marginal cost. That means from the miner's perspective, the revenue or gain they could get from the proof of work activity is similar to their opportunity cost, their equipment cost, plus their operation cost. So these type of consensus are typically implicit, and they are fundamentally very difficult to achieve. That's why like proof of work requires so much like cost in terms of electricity and capex and opex. And there's another type of consensus which is relatively straightforward. This is basically for protecting your ledger, protecting the account state of the blockchain. So what you need to focus is just synchronize the state machine across different computers in the network. So this actually can be done very efficiently with the right algorithm. So this is why like Ethereum moved from proof of work to proof of stake, because proof of work is economic consensus. There's no finality for the blockchain. So everything is probabilistic. Um, but proof of stake, because it's a deterministic algorithm, I mean, you can achieve deterministic through proof of stake and through like, for example, Ethereum's Casper FFG. So this can be done more efficiently. So for Meter, basically what we have done is we combine the two consensus. So we use proof of work, the economic consensus, to create the meta stable coin in the system. We call it the MTR. So we use it as a gas token in the network. The goal is basically to complete Satoshi's original vision to have sound money independent of the fiat system. And we use a proof of stake to to the actual consensus of the synchronization of the state machines across the different computers in the network to protect your ledger, to protect your account. So this is actually very similar to the real world. Miners for gold are always different group of people compared to like accountants or bankers who keep the ledger, keep your account, keep the banking system. And so the separation of the tasks and goals, you can achieve better efficiency of the system. So this is basically one of the design principle in Meter, basically separation the money with the state. And like we mentioned, we use proof of work to create the metastable token, the gas token in the network. So why is it stable? So what we have done is we have packed the cost of first, we use the Bitcoin's proof of work algorithm, the SHA-256, because this is a very well understood, highly competitive, highly popular proof of work algorithm, and also is well studied. At the end of the day, because the competitiveness of the miners, their cost of mining is very close to their marginal cost, which is the mainly the electricity cost for these type of miners. And if you look at the electricity cost across the globe, it's actually the competitive electricity cost across the globe is actually a really good index of the actual purchasing power. And it's very stable across the history. So this chart basically shows the U.S. electricity price. The brown one is measured by U.S. dollar, and the blue one is adjusted for inflation. So you can see like from 1960s till even like recent years, the electricity price essentially stayed the same. Well, if you measure by US dollar, it's almost went up by like 6.5 times. So basically all these 6.5x is basically just inflation, extreme actual printing of the US dollar. While the electricity price, if you measure in real purchasing power, it actually didn't really change over the last 60, 70 years. So this is actually a more stable anchor than any fiat currencies in the world. That's why we have the cost of creating MTR pegged to 10 kilowatt hour of electricity used in mainstream Bitcoin mining. So leveraging miners' competitive behavior to create that equilibrium. So if you look at the price chart of MTR since we launched, you can see like the bottom actually retains fairly well. There's occasional like upward ticks. Those are like based on various reasons. For example, people, because the liquidity for MTR is still relatively small. So at certain extreme times, I think one of the fuel pumps is created by like people bought the wrong token and things like that. So, but over the long time horizon, it's basically trading within range around like 60 cents to $1 or so in the history since we launched, which basically showed that we can actually create stability through complete crypto native mechanism instead of relying on collaterals or external like US dollars. So here we sort of summarize like basically the consensus used in Meter blockchain. So we have a hybrid proof of work and proof of stake. On the proof of stake side, we use the state-of-art hot step 2 BFT algorithm. So I can explain it later with a comparison with other popular uh, consensus algorithm. But basically, the hot stuff 2 algorithm was published in April 2023. So it's basically uh, the as new as it could be. And one of the, I mean, that has a couple of advantage. Um, basically, it's more resilient to network attacks. You can support a more decentralized validator network, and also without giving up on the performance. Um, yeah, so right now we have about like 320 consensus nodes from the community. The requirement for running a validator is actually very low. What you need is basically 2,000 MTRG tokens. Basically, that's our proof of stake governance token. It has the best liquidity in the network. So you need to stake 2,000 MTRG tokens. And then the hardware requirement is basically just 2 virtual CPUs, 8 gig of memory, and like sufficient amount of hard drive space. So one of the things that we showed stability of the network was like we had a like an inscription project or like marketplace uh, launch in December 19th last year. Oh, sorry, I think there's a typo here. It should be like 2023, not 2024. Um, so on that day, there were like 8 million transactions went through the network because a lot of the network nodes were running on AWS Lightsail, which has caps on CPU usage. So many of them were knocked down by AWS. At that time, I think at the extreme was like almost 20%, but the network was still strong and producing blocks smoothly. So that basically shows the robustness of the consensus algorithm itself. So underneath, representing the proof of work and proof of stake, there are actually 2 blockchains in the Meter network. There's a proof of work chain and a proof of stake chain. Basically, all your account system, all the state, all the EVMs are running on the proof of stake chain. You can see like here, it runs much faster. It has like producing a lot of blocks. And on the side, there's a proof of work chain. So this proof of work chain is basically a fork of Bitcoin. And it doesn't record any account information. You don't use any addresses in this proof of work chain either. The only thing it does is basically solving the proof of work puzzles, keep on like solving puzzles and producing blocks around 1 minute per block. So we use a proof of work chain as a representation for the notion of time as well. So because on the proof of stake chain, from time to time, you have to update the information of the validators. For example, new validators coming in, or the existing validator may exit the network, or some of the validator may get into some like malfunction state and has to be like to take out from the consensus committee. So every now and then you need to do some maintenance of the entire of the committee for the consensus network. So you need to have to, so we have a concept called epoch. So basically at the boundary of every epoch, this information will be updated. And we use like basically proof of work ticks to signal the need for epoch change. So every 60 blocks on the proof of work chain will trigger basically an epoch change on the proof of stake side. And that, at that time, the proof of stake side will also vote on the longest proof of work chain all the validators observes and agree on what is the longest proof of work chain, and then it send something back to the proof of work side to make sure the proof of work side just follow that path. So making the proof of work chain also deterministic. So yeah, so here basically, yeah, we talk about the what does the proof of work and proof of stake does. So proof of work is mainly creating the metastable currency. It's the entrance of the proof of work chain is completely permissionless, meaning you don't have to own any network tokens to start participating in this network. And then like since what you mine is the stable currency, later I will explain how you can use the permissionlessly created MTR gas token to exchange for the governance token. And the proof of stake side is basically the real blockchain information serving all the RPC calls when you're interacting with or programming with the blockchain. That's why all the addresses are completely compatible with Ethereum style addresses. So by doing this, we can actually combine the benefit of both worlds for proof of work and proof of stake. Because on the proof of work side, you no longer have the model is different. Instead of have a fixed block reward, the block reward for the blockchain for the proof of work blockchain is actually increases as the more hashing power comes into the network and decreases when there are less power and computation in the network. And almost it can actually goes down all the way to zero. So basically, there's no need for compete anymore. You only have to go through the proof of work process when there's need for newly created gas token in the network. So that process make it very green. So we actually have a comparison of such a economics with the cost of U.S. Mint and Bureau of Engraving for printing U.S. dollars. And to support the size of the U.S. economy, if you use such similar approach, the cost of proof of work will be similar to the annual budget for these bureaus. So it can be as efficient as fiat currency. And also the proof of work make the network permissionless. And you don't have to own anything to participate. On the proof of stake side, we can have higher performance. And also we can immune to a lot of proof of work, proof of stake related problem, like rich get richer, nothing at stake, long range attack, those type of things, because now there's notion of time and permissionless entry to the system. And also through the design of the system, we can basically use a governance token to continuously evolve the network and encourage collaboration between the different participants. So here, so I will talk a little bit about the model between the two tokens. So as a validator in the network, you participate in the validating of all the transactions and the ledgers. And in typical proof of stake network, you will get inflated inflation from the proof of stake tokens. But in the meter network, it's a little bit different. So the inflation of the proof of stake tokens are actually put into an auction that lasts like 24 epochs, basically like roughly 1 day. So at every epoch, basically the participants of the validators will receive rewards, but the rewards are in the MTR, the gas token. So where does it come from? Actually, because of the ongoing auction of the network, every day, every 24 epoch, when the auction, in order to participate in the auction, you have to use the gas token, the MTR token, to participate in the auction. And the proceed of the auction is the inflation for that day in the proof of stake MTRG tokens. So essentially, you use the gas token to bid on the newly minted or newly created governance token. And the reward for all the validators are actually in the MTR gas token. And it's come from yesterday's, it's from the yesterday's auction proceeds collected, basically the MTR token collected through the auction. And then the validator can either decide to just keep the MTR token or participate in the auction. We have a like automatic participation option for the validators as well. So you can choose whether you want to receive MTR token directly or basically participate in the auction to get the to convert it to the MTRG governance token for validation. I think most of the people nowadays choose to just automatically participate. So basically, using this mechanism, we link the tokenomics of the two tokens, and obviously on chain on different dexes, you can swap for like among the two tokens as well. And we also have gasless transaction. I mean, gasless transaction service that can help you to convert MTRG to MTR without owning any gas. But basically, this is one of the underlying mechanisms. Maybe you will have to be aware when you like participate in the meter ecosystem. So basically, the architecture of the meter blockchain, we try to like design a layered approach. The consensus layer basically is at the bottom, and on top of that, it's a state of all the users' account, basically the EVM, like underlying states for the EVM. And then we have a like a meter scripting engine. Basically, this engine serves all the like staking, validation related things, and also we can plug in any interactions with the underlying account abstractions for the user. And on top of that, there's running, currently we have EVM running, but you can add different VMs and other like protocols on top of the meter scripting engine. So yeah, we are basically, we have a like a meter SDK, which combines like everything together. The meter SDK, you can have the option to run it as just a proof of stake only blockchain without the proof of work part as well. So here is like a comparison of different consensus algorithms. Currently, you probably see in the space. So Tendermint is a relatively older consensus algorithm. So it's basically based on PBFT, which is invented in the 1970s. So one of the things for PBFT is if the block proposer fails, there's actually no elegant algorithm that can help to transition to a different block proposer. So Tendermint did like a sort of a shortcut. So basically it assumes all the network are synchronous, means they're highly synchronized in time. And then, so the protocol can assign a fixed time slot for all the participants or all the validators in the network. Because such assumption, the decentralization degree for Tendermint is very limited. So you can see most of the Tendermint power network only have 100 or up to 150 validators in their network. But one of the things is Tendermint can be like a deterministic. So every block in the Tendermint blockchain are typically finalized and achieve a relatively high performance. Avalanche is like a newer algorithm. it's actually doesn't have the synchronized assumption for the network nodes, and can be pretty high performance. The only thing is the tenor avalanche consensus is probabilistic, meaning like you have to assign like certain threshold you can assume. For example, how many confirmations in order to for the transaction to be really finalized. So hot stuff or hot stuff too. Actually, the Ethereum FFG, you can view it as a variant of hot stuff. And Meter is basically running on hot stuff too. So the benefit is, but we took a little bit different trade-off to Ethereum. So we try to strike a balance between the performance and the decentralization. So, and the meter consensus, meter implementation design. So we don't have assumptions on the network synchronization, just partial synchronized, meaning the network can temporarily like be in a like out of order states, and then eventually the network can be fully connected with reasonable delays. But we can achieve a deterministic decision, which means like every block in the meter network is completely finalized. All the transactions are finalized, which is preferred for like trading type of applications. And also, we can achieve decent decentralization by having thousands or even tens of thousands nodes in the network without impacting the performance and finality time. So achieving like much faster finality than the Ethereum proof of stake consensus. Yeah, so here is a little bit on the roadmap for things we're working on the Meter blockchain. So we're looking to bring up a BTC native bridge in the next couple of months. And also, right now, the validation in the Meter network requires the MTRG tokens. But in order to encourage more participation of the blockchain, and also basically have easier access for people to run a validator, we are planning to support multi-asset validation, meaning you can use, for example, BTC or even restaked ETH to start the validator node. And we're also discussing with the Cosmos team to provide an alternative BFT implementation to their Tendermint or Comet BFT implementation using Meter's hot stuff too. We're working on like performance enhancement techniques like parallel EVM. We actually already support some aspect of the parallel EVM in the Meter network already. For example, if you're using the native interface instead of the RPC interface, you can send multiple transactions in the same TX. But yeah, we're looking at ways to make the EVM more like parallelized and have some performance improvement by leveraging multi-core system on the validator machines. And finally, we're looking at the database optimization. So if you look at today's high performance blockchain systems, the bottleneck is actually no longer consensus, but on the VMs, for example, EVM. And the bottom of the VMs are typically the I/O performance of the database, because today's database is not really designed for the key value store type of data access pattern used in like EVM and other blockchain VMs. So there are ways you can optimize the database for better caching, better performance. So that's one of the things we're researching on and basically continuously improving on the Meter blockchain side. So yeah, I guess this is basically a more detailed dive of the Meter blockchain architecture. If there's any questions from the audience, feel free to raise. And then even if it's not directly related to today's topic, if you have any questions related to the hackathon itself, feel to raise those questions.
Perfect. Now we've got a handful of viewers here. We'll give some time for any questions. And if you are listening to this in the future, you may ask any questions on Discord for the hackathon, or you can tweet Meter at Meter.io. Okay. So it looks like we are good on questions for right now.
Mm-hmm. Yeah, so this is our block explorer.
Oh, awesome.
You can see the number of validators in the network. They are all validating the network. And if you look at the blockchain, there's two blockchains. The proof of stake side shows the details of the validator, their distribution, and the proof of work side. This is a hashing power currently in the network. Yeah.
Oh, someone asked, is MTR like a stable coin?
I think I mean you can call it the stable coin, but it's not really pegged to US dollar. So because most people when we talk about stable coin, they're just thinking about like pegged to dollar. But MTR is more like an independent currency of economic equilibrium. Just like, for example, euro to US dollar, they are completely independent currency, but the fluctuation is within a range, and you can use it as a unit of account for exchanges.
And then let me see if we have any more.
And the best thing is it's completely crypto native. You don't need to have any like US dollar reserves or like collaterals to keep the equilibrium.
Perfect. Okay, we'll see if we have any other questions that come in, just in case there's a slight delay. Okay, last call for any questions. All right. Well, thank you so much, Johan.
Thank you, Annalisa, for
Yes.
hosting the second workshop, and thank you everyone for participating. And good luck.
Oh, wait.
There's one more
Oh,
question.
sorry. Yep, right at the buzzard. But let's see. So MTR not too volatile like other assets. This is the question.
Where is the question?
Oh, it was on YouTube. They said, so is MTR not too volatile like other crypto assets?
Yeah, so basically the goal of MTR is create a crypto native stability. So you can use it as like medium of exchange and unit of account for transactions. So it's typically trading within a range to like US dollar and maintaining long-term purchasing power stability.
Awesome. All right, perfect. Let me just ping them and let me know we got an answer. All right.
Okay. Yeah.
Well, we will go
Thank you,
ahead
everyone.
and end the
Yeah.
session. Yes, thank you very much. And if
And,
anyone has any other questions, oh, sorry.
mhm.
Feel free to give us a shout on Twitter or give Meter a shout,
Yeah,
and I'll dish
or
it
on
to you.
Discord. Yeah. And good luck
Yes.
on the hackathon.
Yeah, very good. All
Mhm.
right. Thank
Thank
you. We'll
you.
see you soon.
Bye.
Bye-bye.